Hello everyone, back at the battered old whiteboard now. I need to talk to you and do some planning about the watertight cylinders and how we're going to build them and what the dimensions are going to be. As you know, we're going to have a central section, and on either end we're going to have two pistons. And one of the questions we've got to ask about all of that is, how does it all fit together? How does it come apart as well? Because there's going to be electronic stuff in there, there's going to be a whole lot of different bits and pieces. So I've been giving this a lot of thought, naturally enough, and I like the idea of coming up with something that sort of is similar to other boats, but I never ever do. It's a real problem. So I'm going to do this in my unique way, and hopefully you'll be able to follow this and it'll make sense. There are some basic principles about how much ballast we need. We'll calculate that out and we'll build the watertight cylinders around that. I've got this lovely material. It's 100 millimeters on the outside. The wall is 3, makes it 94 on the inside. I have to cut bits of this up. I've got in total everything I need here. So I'm going to devise this so that it all fits together. Now the first thing I'm going to say is, what I will do is have a central piece, and then I'm going to have sort of like snap-in O-ring connectors to hold it all together. And they will sort of fit in here. I'm not drawing them properly right now. And then the piston section will be on either side, but at the 90 millimeter part I'm going to glue in a bulkhead into those piston segments. As you've seen, I'm going to attach the motor in here and the gearbox, and the piston's going to sit there and go in and out in that. So that's actually going to be the piston length there. This is going to be the total of the watertight cylinder volume that we have. As the pistons go in and out, the pressure in there is going to increase and decrease, and I'm going to use a very traditional way of looking after that, and I'll show that to you in a minute. Pretty excited about that. But let's talk about the dimensions of this to begin with. Now what I want to do is fit 2 lipos into the central section. And if we were to look at it like this, there's going to be a bulkhead running across, and the 2 lipos are going to sit side by side like that, maybe with a divider in between, maybe with another divider there to hold them upright. And above that is all of the electronic gear, and there might be another shelf on up there for some other bits and pieces. I'll need to access that and pull it out, and I'll need to be able to easily get, obviously, the lipos in and out. So these are the kind of things that I'm going to have to really think carefully about. So my plan is to make 2 joiners for either end of that central piece, and one's going to look like this. In fact, it might be this one. I think the dimension's wrong on this, but I'll check that. And the other one, though, is going to be fixed. It's going to be glued in. Let me explain to you how I think that should work. So here is my central section where the lipos fit. In this end I'm going to have my removable joiner that's going to fit in here, or it looks like that sort of, but I can pull it out at both ends. On this end it's going to be glued in, and it's going to join on then to the other pistons. So the pistons will both push on, but this one will be fixed. The reason I want that one to be fixed is so that I can pull this out and have this end of the watertight cylinder completely open. But at this end, in this fairly solid piece that I'm going to glue in, I'm going to be able to fasten my shelves, or at least screw them onto that material there. Also, this is the section that the wires are going to come out for the various other components. This is the point where something's going to come out, plus the pressure gauge and a bunch of other things are going to come out at that point. This front one is going to be much finer. It's going to slot into here and slot into the other one, won't have the room to put those on. That's another reason. So this is going to be the fixing point. It's going to be the point where the wires come in and out. So that's how I see that sort of working. So let's talk about dimensions for a moment. So there's a general principle, that is this: if you have a watertight cylinder and that is 70% of the volume is all of your electrical gear and that the ballast is around about 30%. On my boats it ranges between, I think, about 28 or 9 and up to 35, but that gives you plenty of buoyancy, that 30%. So that's what we're going to aim for. So I've been doing my sums. Let's work it out. The central ballast is going to need to be have space for 180 millimeters in order to fit these lippos with plenty of room. I'm also going to need about 11 more at that end to accommodate the interconnecting piece with the O-ring, and I'm going to need another 6, I think it is, at that end for the glue-in stage, which means this is going to be a piece of 197 millimeters, that central piece, and that's going to be plenty of room for the rest of the electronics. Now let's look at the piston section here. You can see that, can't you? So the piston section is going to have glued into it a bulkhead, and that's going to be the fastening point for the piston, which is going to run through there. That's going to be the piston. Underneath that is the motor and the gearbox and so on, and I know that for the motor and the gearbox to fit in, I need at least 80 millimeters. I also know that this is going to protrude in, the other end of this is going to protrude in another 11. And I know that this is 6, and if I take this to the end of the piston, I've got another 20. So that actually adds up basically to 110 millimeters. Reverse that at the other end, we've got 110 millimeters up into the piston at that point. So the question then is, how big do the pistons have to be? Easy, maybe not quite. So what I do know is I've got 197 in the middle, I've got 110 in the bow, another 110. This is looking at the internal size of the watertight cylinder, but I also have 110 in the motor room right at the back. So that all adds up to 527 millimeters worth of watertight cylinder, which means 30% rule, I need 225 of piston length. Got 2 pistons, that's one, call it 110 each. That is how long the pistons are going to have to be at either end of this. So what we know is that the central piece is going to be 197, 200. That the bow piston section is going to be 220. That's including the piston now. That the stern piston section is going to be 220. And that right in the stern we've got another 110 for the motor room. So the next step is, how do we fasten this, how do we put it in the hull, and how do we hold it together? This is, I really like this. I've had some evenings of thought around all of this. And what I've created is this. It's a piece of plastic, and I've machined it out to 138 across, and I know that that is the interior dimension of the submarine. And then I've put a groove in there that's going to fit the 100 millimeter section of the watertight cylinder. It's going to hold it in, just fit over it like that. So my plan is this. Before I put this in the boat, because this is all going to be able to be lifted out and lifted back in, I'm going to put my pieces of plastic on the front, like that. So this is actually going to be lower at this end and this is going to be higher, and you can see that's how that is now. Then I'm going to get a couple of bolts and I'm going to drill them right the way through there. Put them on both sides of this, bolt it together, and this thing will be able to take a fair amount of pressure, both positive and negative, and it will be terrifically watertight. The areas where I might have concern are the edges, obviously the seals on the pistons, these seals here, there and there, and obviously where the wires are going to come out. Once I've worked on those, they're going to be leak-free. I'm going to make sure that's completely leak-free. Then the next thing to do is to build into the bottom of the boat a little arrangement here so that this plugs straight in. Mind you, this is going to have holes in as well, obviously, to let the water in and out of the piston. That's pretty obvious. So that I can lower this into the boat and just latch it in at that end, and then maybe have a bolt here that screws that back end in, so I can bolt that together, slot it in, bolt the bottom in place, and that's going nowhere. Then I can put a bolt in the top of here, not quite that big, you just got the idea, and that holds the top of the casing on. I really like that. I think that's really simple. So these little things are going to have several purposes. One is to hold the watertight cylinder, the other is to keep it from bursting apart, to enable it to be plugged into the bottom of the boat, and to fasten the top of the boat to it. I reckon that's really sweet. Okay.